2. All right, we already know the rules, 1.5 hour. All right, because we're working through it a little bit slow, of course, we'll be going a little bit over that, but let's get to this paper. So, question 1, it says a quadratic equation is given by ax squared plus bx plus c, and it says that the roots of the quadratic equation are alpha, which is 1 minus 3i, and beta. Calculate what is alpha plus beta. Now, we know how to do this. Once they give us alpha is 1 minus 3i, then beta is going to be 1 plus 3i, because we know that complex roots, they occur in conjugate pairs. So we can say alpha plus beta is going to be equal to 1 minus 3i, that's for alpha, and we know what beta is. It's going to be plus, beta is 1 plus 3i. All right, so we work out what is 1 minus 3i plus 1 plus 3i. That will give us alpha plus beta. 1 plus 1 is 2, and then minus 3i plus 3i is 2. So that's alpha plus beta. So alpha plus beta is 2. That's how you get alpha plus beta. The next thing we're going to want to know is what is alpha times beta. Now, alpha times beta is going to be 1 plus 3i times 1 minus 3i. But that's just the difference of 2 squared. 1 minus 3i times 1 plus 3i. Given that we know that this is the difference of 2 squared, we know that it's going to be first term squared minus second term squared. So it's going to be 1 squared minus 3i all squared. And then we know what 3i all squared is. 3i all squared is 9i squared, and minus 3 squared is 9, I squared is minus 1, so it's 1 minus 9, so that becomes 10. So that's alpha beta. Nice and easy, soft. That's 10. That's the value of alpha beta. So this question is finished. It just wanted alpha plus beta and alpha beta. Nice. So that's 3 marks. Let's look at the next part of the question. The next part of the question says, hence, show that the equation with roots 1 over alpha minus 2 and 1 over beta minus 2 is given by this. Now, one thing we do know is that the equation of a quadratic is given by x squared minus the sum of the roots times x plus the product of their roots, and that is equal to 0. That's how we find the equation of a quadratic. All right, now we need to find what is s. S is going to be equal to 1 over alpha minus 2 plus 1 over beta minus 2. That's how we find the sum. Not plus 1 over alpha minus 2 plus 1 over beta minus 2. So in order to add them, we're going to have to use the LCM. So find their LCM. The LCM of alpha minus 2 times beta minus 2. That's going to be the LCM. Alpha minus 2 times beta minus 2. And then we go alpha minus 2 into this denominator leaves beta minus 2. And then beta minus 2 into this denominator leaves alpha minus 2. And so this works out to be, in the numerator, it's going to work out to be alpha plus beta minus 4. So it's alpha plus beta minus 4. That's the numerator. Alpha plus beta minus 4 over, in the denominator it's going to work out to be alpha beta minus 2 alpha minus 2 beta minus 4. So in the denominator it's going to work out to be alpha beta minus 2 alpha minus 2 beta. This is just the denominator, minus 2 alpha minus 2 beta plus 4. And know what, I shouldn't have squinged it right here, but let's go ahead and evaluate. Alpha plus beta we found is 2, so that's 2 minus 4 over alpha beta is 10, and then minus 2 alpha minus 2 beta is really minus 2 times alpha plus beta, and alpha plus beta is 2 plus 4. So we work this out, and that will give us the sum. So let's put down the sum somewhere up here in black. So the sum is up here in black. It is 2 minus 4. 2 minus 4 is negative 2. It's negative 2 over 10 minus 2 times 2 plus 4. That's 10. So the sum is minus 2 over 10. That's the sum. Now let's find the product of the two roots now. Now their product P is going to be equal to 1 over alpha minus 2 times 1 over beta minus 2. So 1 over alpha minus 2, and it is multiplied by 1 over beta minus 2. When I multiply these two, what am I going to get? When I multiply them, I'm just going to get 1 over alpha times beta is alpha beta. So it's alpha beta minus 2 into alpha plus beta plus 4. That's what I get when I work out the denominator. And so the product works out to be 1 over 10. That works out to be 1 over 10. So now that the product is 1 over 10, what does that mean? So getting that the product is 1 over 10, and so now I can find the new quadratic equation. The new quadratic equation is going to be x squared minus the sum, and it's going to be minus the sum becomes plus 2 over 10 times x plus the product, which is plus 1 over 10, and that's equal to 0. So all I have to do now is multiply through by 10. So multiply through this equation by 10, and that will give me x squared. That will give me x squared plus multiply through by 10, I get 10x squared plus 2x plus 1 is equal to 0. And that's how we prove this question. Nice and easy, soft. That takes care of the first part. Now, part B. Part B says the complex numbers are given by u is equal to 4 plus 2i and v is equal to 1 plus 2 times the square root of 2i. And this complete the Argand diagram to illustrate u. So to illustrate u is just going to be on the real axis it's 4. So we go 4, and on the imaginary axis we go positive 2. And say u is this point right here. And so just going to draw a straight line from there. So drawing a straight line from the origin to here, that represents u. So this represents u. Nice and easy, soft. All right. Now it says on the same organ diagram, sketch the circle with equation z minus u equal 3. If we're sketching this circle, the first thing I want to know is where is the circle? Z minus u is z minus 4 plus 2i. So this is what we're sketching, and that is equal to 3. So that means that the radius of the circle is 3. So I'm going to go 3 units across to 7. So I know that, and I'm going to go 3 units below, which is 2. I know the circle going to go through minus 1 here. 3 units across, going to go at 1. And 3 units above 2 is 5. And so then that's the circle passing through these points there. So let's draw the circle now. Let me see. This can work. Not quite. All right, that's it. All right, so just wanted to make sure that the radius is 3. Make sure the radius is 3. Yeah, that should be fine. All right. So we made sure the radius, we can show them that this radius is 3. So this will be the circle that will be z minus u, and that's equal to 3. That's the locus. The locus is a circle with a radius 3, with the center being 4, 2, which is u. All right, so that's what we have. Nice and easy, soft. The next part says calculate the modulus and principal acute argument of z, which is u over v to the 5th power. So first thing, before you work out what is u over v to the 5th power, once you see u over v, this is not in standard form. So we're going to need to rationalize by multiplying by the conjugate of v. Remember, u is 4 plus 2i. Not sure what was v was again. Let's check what was v again. So going back, v is 1 plus 2 root 2i. So v is 1 plus 2 root 2i. So we're going to multiply by the conjugate of the denominator. Multiplying by the conjugate of the denominator is 1 minus 2 root 2i. And so we're multiplying also the denominator by 1 minus 2 root 2i. And that will give us u over v. So let's work it out now. Multiplying them across, 4 times 1 is 4. 4 times minus 2 is minus 8 root 2. That's minus 8 root 2i. Then we have 2i times 1 is 2i. And then we're going to have 2i times minus 2 root 2i. But 2 times 2 is 2 times 2, that's going to be 4. That's going to be minus 4 root 2i. And then I times I is I squared, so it's minus 4 root 2 I squared. And that's divided by, we have the difference of 2 squared, which is 1 squared. So it's going to be 1 square minus 2 root 2 all square, which is the same as, because we have 2 root 2i times minus 2 root 2i being squared, the I square is minus 1, which makes it plus 2 root 2 square. This is plus 2 root 2 square. So remember, this is u over v. So this works out to be 4 minus 8 root 2 plus 2i minus 4 root I squared. But I squared is minus 1. And so this works out to be, let's just make sure we didn't make any calculation error. 4 times 1 is 4. This is minus 8 times root 2i. This is plus 2i. This is minus 4 root 2i squared. So we didn't make any mistake. So it works out to be 4 plus 4 root 2. 4 plus 4 root 2. Then it's going to be plus I times 2 minus 8 root 2. 2 minus 8 root 2. So it's 2 minus 8 root 2. And that's divided by 1 square plus 2 root 2 square. 1 square plus 2 root 2 square, you put that in a calculator. 2 root 2 square plus 1 square, that's 9. So that is u over v. So now I can square this now. I'm going to square this, and that will give me, not square it, raise it to the, well, actually this is actually a much longer method to do it. And so now this is what we get for u over v, and so now we need the modulus of the one u over v to the fifth. All right, the modulus of u over v to the fifth. So first we can find the modulus of u over v. So the modulus of u over v, to find the modulus of u over v, it's going to be equal to the square root of, it's the square root of a squared plus b squared. This is a, which is 4 plus 4 root 2 over 9. Square plus, this is now 2 minus 8 root 2 over 9, and then we're going to square that. So let me put that in my calculator. So we square this, we work out that now. 4 plus 4 root 2 divided by 9 square plus 2 minus 8 root 2 square divided by 9 square rooted. I'm getting 3.28. Just want to check again. 2 minus 8 root 2 divided by 9 square. So that's 1.07. And 4 plus 4 root 2 divided by 9 square. It's 1.15 plus 1.07. That's 2.22 square rooted. I get 1.5. So I get that. This is giving me 3 over 2. All right, so that's 3 over 2. And so what they want is, they want the modulus of u over v to the fifth power. So u over v to the fifth power is just going to be 3 over 2 to the fifth power. It's just going to be 3 over 2 to the 5th power. That's going to give us the modulus of u over v to the 5th. So if you want to simplify, you can. I won't. 3 over 2 to the 5th power. All right. Now they want the argument of u over v to the 5th power. Now the argument of u over v to the 5th power, you have to remember that the argument of z to the n is n arg z. So it's going to be equal to 5 times, it's going to be 5 times tan inverse of y over x. So it's 5 times tan inverse of, I'm going to just call this A, call this B, and call this A. So it's 5 times tan inverse B over A. And you put those in a calculator. So let's work that out. 2 minus 8 root 2 divided by 9, that's B, divided by A. And A is 4 plus, so that's 4 plus 4 root 2 divided by 9. So I get minus 0.96. Tan inverse of that is minus 0.76, and I add that to pi. 2.32 times 5, so I get 11.87. So this, I get that the argument is 11.87, and that takes care of this question. All right, that's the argument. All right, you have to remember you had to add pi to it. Let me not write it like this then. Let me write it as, this is equal to 5 times pi plus tan inverse of b over a, because it's in the second quadrant. Nice and easy, soft. Final part of this question.